Today we're covering section 11.7, rational expressions with unlike denominators. Our main idea today is to subtract rational expressions and add them with unlike denominators, as well as simplify Algebra Standard 13.0. So we're going to start with something that you may remember, adding and subtracting fractions with like and unlike denominators. So we're going to start with this example with something you may have remembered from perhaps 5th or 6th grade. Okay, do you recall how to add these two fractions together? What would you do to add them together? Let's see. We do need to make sure we have like denominators as covered in the video that was prior to this one. So to make like denominators, what we're going to do today is we're going to use factoring as our method instead of just hunting for a number they have in common. So to do this by factoring, what we're going to go ahead and do first is factor each of the denominators. So for example, 4 would be 2 times 2, and 6 would be 2 times 3. And to make like denominators, we have to ask ourselves which factor each one needs. For example, 4, if you take a look, it's 2 times 2. 2 times 2 would need a 3 because we need to make them the same. So I call this swapping. We're going to go ahead and give this one a 3 because it's missing a 3. And this one is missing an additional 2, so we need to give this one a 2. But keep in mind, whatever you do to the bottom, you're going to need to do to the top. So now this is what it's going to look like. I have 1/4 plus 5/6. So since this was 2 times 2, it needed a 3. We're going to go ahead and give it a 3. Give this a 3. Whatever you do to the bottom, you do to the top. And same thing with the 5/6. I'm going to go ahead and give that one a 2. So I'm going to give the bottom and top a 2 as well. So now we're going to go ahead and simplify, and this would now become 3/12 plus 10/12, and we've made a common denominator. Now to add, we would just simply go straight across. So 3 plus 10 over common denominator of 12. So this becomes 13/12, and we are going to leave them in improper form. Okay? So that's what our addition looks like. How would you do the subtraction problem? Let's go ahead and show you our subtraction problem. Our subtraction would be 5/6 minus 1/4. So how would you go about doing this problem? Let's go ahead and do it the same way. Okay? So I've got 5/6 minus 1/4. I'm going to go ahead and factor. 6 is 2 times 3. 4 is 2 times 2. Now we've got to swap our factors to make them exactly the same because we need a common denominator. So I'm going to multiply this one by an additional 2 because I need 2 2's. So whatever I do to the bottom, I'm going to have to do to the top. And same thing on this one, I need an additional 3. So whatever I do to the bottom, I'm going to do to the top. So now I have a new fraction here, an equivalent fraction. 5 times 2 is 10 over 12 minus 3 over 12. And when I do my subtraction, same thing. I'm going to go straight across again. So this is 10 minus 3 all over common denominator 12. So this is now 7/12. And that would be my answer. Okay? So knowing that we've done this before, we're going to use the difference today is going to be, we're going to do this with polynomials, monomials, and binomials, and trinomials, and such. Okay? So moving on, let's go ahead and take a look at, we're going to go ahead and open up the steps here, okay? So to add or subtract with unlike denominators, the first thing we're going to have to do is make common denominators, okay? And to do that, the first thing we need to do is place our parentheses as needed because you will see many binomials, okay? So you want to make sure to put your parentheses as you need to, okay? We're going to factor our denominators completely, as I did in the case of 5/6 and 1/4 that we did for our addition and subtraction examples. We remember that we factored completely for those denominators, just like that. Okay, so we're going to do the same. We're going to factor denominators completely, step 1. Then we're going to swap until the factors in the denominator are the same. Be sure whatever you give to the bottom, you also give to the top. You need to make sure they are exactly the same. Then, step 3, we're going to rewrite it over one common denominator, okay, which is what we did in our addition and subtraction example as well, okay. Then, step 4, we're going to add or subtract and then simplify, combine like terms as we need to, okay. And then finally, the last thing is factor to simplify so we can reduce further, okay. So let's go ahead and go to our first example. You're going to notice today we're going to do lots of examples so you see many cases of this, okay? Okay, so first example, example number 1. Let's go ahead and go to our first example here. I've got 7 over 6a squared plus 5 over 3a. So what we've got to do is create our common denominator. So first thing we're going to do is factor. So this is example number 1. Okay, we're going to go ahead and start factoring. What is 6a squared? Well, 6 is 2 times 3, and a squared is a times a. 3a is just 3 times a. So now what we're going to do, once we factor completely, we're going to start swapping. Okay, so start swapping your factors. Well, what does this side need to be the same as the other side? Well, let's see, it's got the 3 and it's got the a, so we don't need that. It seems like it has everything the other side has. So let's go to the other side. 3a would need a 2, so we need to give it a 2. We also need to give it another a, so we're going to give it 2a. Whatever you do to the bottom, we're going to do to the top. So now we're going to rewrite this. So we get 7 over 6a squared plus 5 times 2a gives us 10a over 6a squared. Now you notice they have a common denominator. So now we're going to go ahead and go straight across and put this over one common denominator, which is 6a squared. So 7 plus 10a. And we're going to check, can this numerator be factored? And the answer here is no. So this would be my final answer. Okay? So let's go ahead and do another example so you kind of get the hang of this. Okay, so then what I'm going to ask you to do is go ahead and try this one on your own, okay? So we'll make this a your turn. Okay, go ahead and give this one a try. Pause here. Now that you've tried it, let's go ahead and check to see what you got, okay? So we get a common denominator, same thing. This is 3 times x. This is 2 times 3 times x times x. We're looking for a common denominator. This needs a 2 and an x, so we're going to go ahead and give it 2 and x. Whatever you do to the bottom, you do to the top. And then we're going to rewrite so that we have everything over a common denominator. So this is 14x over 6x squared minus 3 over 6x squared. And we end up with 14x minus 3 all over common denominator 6x squared. Unfortunately, we can't factor again on this one, so this would be our final answer. Okay, did you get that one right? I hope so. Okay, let's go ahead and try another example together right now. Okay, example number 2. Okay, example number 2. Now we're talking about some binomials in the numerator. Right now, what you may want to do is put those parentheses in. Okay, next, let's go ahead and factor 5 times z, and this is just z. So if you take a look, are any of these denominators missing anything? So you notice this one needs another 5, so I'm going to go ahead and give it an additional 5. So multiply by 5, whatever you do to the bottom, you've got to do to the top. So now we're going to go ahead and simplify. This will become z plus 2 over 5z. And if you notice on the top, I've got to actually distribute this, right? So to distribute it, I'd get 5z minus 30 over 5z. Now I'm going to go ahead and simplify going straight across, okay? So if I go straight across, on this one, I'll get z plus 5z gives me 6z. Then I have a 2 minus a 30, so this minus 28 over 5z. Now, I could factor this. There is a multiple of 2 here, so I'm going to go ahead and pull out the 2, and then I would get 3z minus 14 all over 5z. And this factor, unfortunately, I cannot cancel. So either of these answers are acceptable. You could have this as an answer, or you could, of course, have this as your answer. So either one would be fine, okay? Okay, so what I'm going to ask you to do right now is go ahead and try a problem. Go ahead and try on page 149 in your workbook, okay? Try problem number 5, okay? And that's for class tomorrow, so go ahead and give that a try, okay? Moving on, let's go ahead and try another example, okay? Now if you take a look, my denominators in this one are completely skewed. If you take a look, I've got 5 minus a, and now we're talking binomials, okay? So this is 5 minus a, and this is a squared minus 25. So let's go ahead and factor at this point, okay? So 5 minus a is just 5 minus a, but if you take a look at this, this is dots, so we would factor this as a plus 5 and an a minus 5. Now, if I take a look at this, you'll notice that this 5 minus a is very close to this a minus 5, so what we're going to go ahead and do is we're going to go ahead and create a binomial that looks like that. So remember what we did in previous videos. We could factor out a negative 1. So first thing, I'm going to go ahead and use my commutative property and switch this. Next, I'm going to factor out a negative 1, so this becomes a minus 5. Now I have an a minus 5 here and a minus 5 here, okay? So next, I'm going to go ahead and see if I need to swap any factors right now, okay? So if I take a look, they both have an a minus 5. This side has a negative 1. This side has that a plus 5 additional. So what that means is this side needs an a plus 5. So I'm going to go ahead and give it an a plus 5 on the top and on the bottom. And see that negative 1? What we can do is we can take that negative 1. We could go ahead and give the other side a negative 1. Or what we could go ahead and do is move that to the top, because remember how our negatives, if I have one on the bottom, I can move it to the top or place it in the middle. I'm going to go ahead and move that to the top. That way I don't have to worry about it on my denominator, okay? So what we're going to go ahead and do right now is go ahead and do exactly that, move it to the top. So I'm going to have a negative 1 up here instead of down here, okay? So now, if I take a look, this is what I end up with. Okay, the negative 1 multiplied with that negative 3 to become a positive 3 times the a plus 5 we gave the top, okay, plus there was a 5 on the other side, which we left alone, all over my common denominator is now a plus 5, a minus 5. I'm not yet done with this. I have to go ahead and distribute this 3 out, okay, so now this becomes 3a plus 15 plus 5 all over a plus 5, a minus 5. And then I need to simplify. So I have 3a plus 20 over a plus 5, a minus 5. And now I'm going to look at the numerator. Can I factor that any further? I cannot. So this would be my final answer. Okay? So beware of this one. I would put an example on, I would make sure to put a star on example number 3. This is one you have to be very careful of because of that negative. Okay? So that negative right here. Okay? Okay. So, next example, let's go ahead and take a look at example number 4. Now this one is a subtraction one, so beware. This is subtraction with a binomial denominator. Okay, so on this one, I need to be very careful to make sure that I watch out for that minus sign here. Okay, that minus sign can be rewritten as part of the top, because remember what we just said about negatives. Remember that negatives, I could write a negative in the middle, like if I had negative 1/2, right? Negative in the middle, okay? Or it's the same as a negative on the top, or it could be the same as me taking that negative and putting it on the bottom, okay? Remember that negative could be in different places, but there's only one if you take a look, okay? So we have to be careful of that minus sign there, okay? So let's go ahead and give this one a try, okay? So I'm going to go ahead and factor my x squared minus 5x, which has a common factor of x. So this is GCF of x, so this is x minus 5. This is already factored. This is an x minus 5, okay? So now if I take a look, what I need to do is this one needs an additional x, right? So I'm going to go ahead and give it an extra factor of x. Whatever I do to the bottom, I'm going to do to the top. Okay, keep in mind there's that negative that I need to apply to the top, okay? So when I do this, I'm going to go ahead and rewrite now, okay? It becomes 2x minus a negative 3x times x all over x times x minus 5. Okay, now I've got to simplify this portion. Okay, so now I've got 2x plus 3x squared over x minus 5 times an x, of course. Okay, not quite done. I need to see if I can factor. If you take a look, numerator, there's an x here. So I'm going to factor out a GCF of x. I get 2 plus 3x. And on my denominator, I also have an x times x minus 5. So now if you take a look, I have a common factor here. So we can go ahead and cancel those out and reduce. So then I end up with simply 2 plus 3x on the top with an x minus 5 on the bottom. And that would be my final answer. Okay? So let's go ahead and take a look at another example. Okay? So example number 5 here. Okay? Example number 5. Okay, now if you take a look, we've got a trinomial as part of our denominator, right? So let's go ahead and factor that out. Okay, that is a PST. If you notice first squared, last squared, that'd be a 1, and then a positive 1, and this is an x squared. So if I take a look, I get 1x as my center, and if I multiply by 2, it does come out 2x, so it works. So this is actually x plus 1 quantity squared. Or if you'd rather write it, you can write x plus 1 times another x plus 1. Okay? And on the denominator on this side, you have just x plus 1, which means this one is missing an x plus 1. I'm going to go ahead and give it an x plus 1. Whatever you do to the bottom, you do to the top. So let's go ahead and simplify that. This now becomes x plus a 1 times an x plus 1 over x plus 1 times x plus 1. Now I'm going to simplify this portion here. This needs to be distributed, so I end up with x plus an x plus 1, because I distributed a 1, over x plus 1 times x plus 1. And you end up with a 2x plus 1 over x plus 1, x plus 1. And if you take a look, I cannot factor this any further, so this would be my final answer. Oops. There we go. That's a 2x plus 1. Okay? So it's your turn. We're going to go ahead and have you try. Go ahead and try in your workbook on page 149, problem number 13. Okay? Okay, and our final example today, we're going to go ahead and do this one. This is where the denominators are completely different. Okay, this is also a subtraction problem. This is example number 6, final example here. Okay, if I take a look, I'm going to go ahead and factor first thing and place some parentheses as needed, of course. I've got parentheses around here. I can do this as well. Okay, so I've got an x plus 1 here. I've got an x minus 1 over here. So it looks like they're very close, but this one needs an x minus 1 and the other side needs an x plus 1. So I'm going to give this an x minus 1. I'm going to give this one an x plus 1. Okay, whatever you do to the bottom, you've got to do to the top. Okay, so then we're going to go ahead and FOIL that out, of course, because on the top I now have an x squared minus 1 times an x minus 1 minus, and that minus sign comes from this minus sign, minus an x squared plus 1 times an x plus 1, all over x plus 1, x minus 1. Okay, so I've got to do some foiling right now. Let me go ahead and do some foiling. So x squared minus 1 times an x plus 1, if I FOIL, I end up with x cubed first. Outer will give me a negative x squared, inner negative x plus 1. Okay, that's on this one. Minus, be very careful, I'm going to put this in red. This minus sign is right here, that minus sign, minus, and I'm going to do this FOIL, but I'm going to put that in parentheses because what happens is that minus sign is going to have to be distributed later, okay, because I'm subtracting this whole amount, okay, and I'm going to go ahead and FOIL this one, x cubed plus x squared plus x plus 1. And now I've got to make sure this is all over the common denominator, x plus 1, x minus 1. Okay, and then finally, see that minus sign, we've got to distribute it now, okay, to simplify. So if after I distribute, you'll notice you have x cubed minus x squared minus x plus 1 minus an x cubed minus an x squared minus x minus 1 all over x plus 1, x minus 1. Now, let's go ahead and simplify. Do we have any like terms here? I see a minus x cubed and x cubed. These cancel out. A negative x squared and a negative x squared, they will not cancel out, so I'm going to leave those alone. I've got a negative x here, and I've got my copy error here. These should all be positive. Okay. Oh, no, that's correct. That is a negative. Okay, we distributed, that's right. So this is a negative x squared, and this is a negative x squared, so that stays. Got a negative x, that stays. Okay, these two stay. And then I notice I have a positive 1 and a negative 1. Now that cancels. Okay, so then I end up with, let's see, which one stayed? Our negative x squared and our negative x squared here. So that makes negative 2x squared. And I've got a negative x here and a negative x. That gives me another negative 2x all over an x plus 1, x minus 1. Finally, I'm going to go ahead and factor to see if any of that can be reduced again. So if I take a look, they both have negative 2 and they both have an x. I'm going to factor out negative 2x, which leaves me with an x minus 1. And this is x plus 1, x minus 1. And if I take a look, hey, these are the same. So these can cancel out, which means I'm left with negative 2x over an x plus 1 as my final answer. Okay, so now it's your turn. Okay, we're going to have you go ahead and try in your workbook the final try problem, workbook page 150, problem number 11. Okay, and with that, we'll see you tomorrow.